Hi everyone, it's me Devangna, and this is my third YouTube video. Today I'm going to talk about neuroscience, so without wasting much time, let's just get into it. So, I finished my master's in neurosciences last year, and one of the most common assumptions that people make is that studying the brain gives you answers, clear answers about the mind, behavior, and yourself. The truth is, it does give answers, but not in the way most people expect. Let's say studying neurosciences didn't remove any confusion from my life, but it changed the way I think of confusion. It changed the way I understand confusion. And in this video, I want to talk about what neuroscience can explain really well and what it still cannot. One thing neuroscience is particularly good at is explaining mechanisms, like how processes in the brain might give rise to experience. Take perception, for example. In neuroscience, perception is not understood as a simple passive process where the brain is just receiving inputs from the outside world. Instead, perception is considered a very active process where there is constant interaction between the signals from the outside world and the internal models in the brain of the outside world. Hold this thought. What this means is that the brain is constantly generating predictions about what it expects to perceive based on past experience, context, or prior knowledge. And the incoming sensory signals are then used to update or correct those uh, predictions. Yeah, predictions formed by the prior knowledge. So we can say that perception is not a direct readout of reality. We don't even know what reality is. Like, perception is maybe a dynamic process of inference, if that makes any sense to you. Feel free to just ask any questions in the comment box, but I'll try to explain it further, or maybe in the next few videos, I'll try to explain it in more detail, but now I'll just give you a generalized idea. So, uh, I would say that from a neuroscience perspective, what you experience at any moment is the brain's best estimate of what is out there. Just an example, but when your brain is under extremely stressful situation, or when it's going through some trauma, your perception might be different. Like you might perceive things differently compared to when the brain is in a healthy state. So that's an example, but there are many other examples of perception, like difference in perceptions as well. We can cover those in the future videos. Another area where neuroscience has made some significant progress is memory. So we know at a very basic level that memories don't just form on their own, they don't just appear randomly, but they're supported by some physical changes inside of the brain. So when you're experiencing something new, when you are learning something new, or you're feeling a new emotion, certain connections between certain neurons in the brain might change. The connections might become stronger or weaker, and this change suggests that a pattern of activity inside the brain might happen again. So, in neuroscience, we just give names to these processes. For example, there's this term called long term potentiation, or LTP, which refers to the connections between two or more neurons becoming stronger over time. So it helps the neurons to communicate more easily. And there is this process called long term depression, or LTD, which suggests or which refers to process where the connections between neurons become weaker over time. So it helps the brain to stop reinforcing information that isn't useful anymore. We also know that memory isn't just stored in one particular place. Hippocampus, for example, is especially important in forming new memories, but over the time, memory formation might include multiple different areas across the brain and multiple different networks between different brain regions as well. So, memory is more like a process that unfolds across networks, and it's not just a mere file saved in a particular location. But here's where things start to get interesting. Even with all of this knowledge, neuroscience still doesn't fully know what memory actually is. And that's a big question because we don't yet know how experience becomes something that can stay with us for years and how remembering something can subtly change the memory. So I would say it's a really amazing it's a really amazing example of how neuroscience has gone quite far in explaining the biological mechanisms, but not all the way in explaining the lived subjective experience. So far, I have talked about areas where neuroscience has explained mechanisms pretty well, but there are areas where it starts to struggle. One of them being subjective experience. So, uh, neuroscience can tell us a lot about what's happening in the brain when somebody goes through a novel experience. We can measure brain activity, identify reliable patterns, find strong correlations between neural processes and the experience. But we know that correlation is not the same as causation. So, in many cases, we can tell what is happening in the brain when an experience occurs, but we cannot tell why that experience arises or what is causally producing that experience. Understanding causation in the brain is incredibly difficult because brain activity is distributed across different diverse regions in the brain. It is dynamic and it is deeply interconnected. So, it is extremely hard to isolate simple cause and effect relationships. It's a much deeper issue, and I won't go into it in detail in this video, but I would really like to make more videos on it in the future. But I just want to say that this is a very important reason uh, to why explaining subjective experience remains a challenge in today's world. And this becomes especially clear when we deal with complex topics like consciousness. So, neuroscience can reliably link the patterns of brain activity to different conscious states, but it still does not provide a complete causal explanation of how those neural processes can give rise to conscious experience. And a major reason for that could be that something as complex as consciousness might not be fully explained or understood by neural mechanisms alone. So, what I'm trying to say is neural activity is definitely necessary, but it might not be sufficient. So, consciousness might involve multiple levels of description, and it is very important to study it from an interdisciplinary approach. And this is where other disciplines become essential. For example, math and physics offer us tools to study complex systems, emergence, causation at across different scales. And it's very hard to capture those dynamics by focusing on a single neuron or a particular brain area or linear connections between different areas. And at the same time, disciplines like psychology, cognitive science help us connect these formal descriptions to behavior and experience. I would say it's not at all a shortcoming of neuroscience, it's a reflection of the kind of problem we are dealing with here. It requires integrating neurosciences to other different disciplines rather than expecting neural data to give us all the answers to these complex questions. Studying neurosciences clearly didn't give me answers to all these questions I had mentioned in the video earlier, but it did change my relationship with those questions. It taught me to be more careful about the difference between mechanisms and explanations and correlation and causation. It's very easy to study in the school that correlation is not equal to causation. It just appears to be obvious. But when you collect your data yourself and you notice a positive or a negative correlation in that data, your brain will unknowingly assume that there is a causal factor here. And it's your job as a researcher to train your brain to not do that. And my master's dissertation really helped me in that. So, yeah, it made me more comfortable with, like, the entire master's degree made me more comfortable with uncertainty. And now I'm a little less harsh about not having clarity all the time. It's really important in life as well. These days I've stopped expecting my brain to answer questions it may not be fully equipped to answer on its own. And instead of seeing those open questions as failures, I am starting to learn that these questions in itself are more important than finding their answers. And this is what this channel is all about. I am not trying to use neuroscience to oversimplify human experience. I'm not trying to turn the brain into a collection of hacks or shortcuts. But I'm trying to use neuroscience as a way to think more carefully about the mind, about experience, about the limits of what we know. And we know that neuroscience cannot explain our entire mind, but it can change the kind of questions we ask. And sometimes that is enough. Yeah. Thanks for watching. I'll try to come up with more such videos and I'll try to teach more about what I know.